Your only option here is going to be I want a 1 for a single node install, or I'm going to do a 3-node install. You enter the IP address or host name, the root credentials for each of the 3 nodes. The very first node you enter is going to be considered the primary node, if you will. And we'll talk a little bit about what that means later. So quick little inventory Ansible job run, sets up an inventory, sets up some variables, some SSH keys and things of that nature. So that runs within just a minute or two, and then your primary node is set up with a definition of your cluster ready to go. Next, you can run a command to look at that information just to kind of verify, okay, what are my hosts? Yep, it got configured correctly. What's my cluster name, my primary host, my virtual IP address, what are my firewall monitoring settings? And, once you've verified that, you got your Yum repositories ready, then you run the PowerVC Ops Manager install command and you just specify the cluster name. That's all there is to it. It goes out and begins multiple playbooks, roles in playbooks to go out and do a lot of installation and configuration work. So this is going to run, in my case, I had 3 nodes, had very limited resources. So I was running on a Power 8 with like half a core on each node, way under the minimum requirements, but I didn't have much choice but to do that to try it. Ran about an hour, okay, set up all the databases, set up the Galera, the MariaDB Galera, did all of the pacemaker setup across all the nodes, got the cluster defined on all the nodes joined all in about an hour's time frame. So not bad for the amount of work that it had to set up, had to do. And you'll notice at the very end of your install, once it's finished, there's a log file, of course. You can go back and look at all of the playbook output if you do have an error. And that's one thing I want to mention too, since this is an Ansible installation. If you're familiar with Ansible, it's what they call antipotent, where you can basically try to run an installation again, and it will go down and pick up and try to install where it left off. It's got the configuration of and checks whether it skips steps or repeats them and so forth based on what's there. So I actually had that happen. I had a network error as I was going through a node install. One of the nodes, for some reason, had a little network glitch, and it couldn't get to the Yum repository for part of the components. It failed. I checked it out, made sure it was working, and then just reran the install command, and it picked right back up, installed on that node, and finished the cluster and worked fine. So that was pretty slick, I thought. You do have the option with these to uninstall a node if you want to start from scratch if something isn't working right. You can certainly use the Ops Manager to uninstall and start again. Anyway, your UI is now at your virtual IP address. So this is the virtual IP that I specified here. And just like I say, works as normal then after that point forward, just your normal PowerVC. Just a quick snapshot here of the space used. Just kind of want to give you an idea. I in my lab, I just have everything under root. I didn't partition out the different file systems. So, but just to kind of give you an idea of the usage, right? I've got 26 gig being used in the primary node 1. The secondary and second and third nodes both used about 20 gig versus 26 gig on the primary. And this is just the vanilla installation, no monitoring, and no PowerVC configuration. So just to kind of give you an idea of disk space usage there. So the install flow is basically installs PowerVC services on each node, creates the MariaDB, the Galera cluster, creates the RabbitMQ cluster for communication, installs and configures Pacemaker and CoroSync, installs and configures the HA proxy on all the nodes, including the virtual IP, and updates all the services and configuration files. So every node runs the PowerVC services, has a configuration file locally. Well, all those service definitions are now using the virtual IP address versus, the original, maybe an original static one, right? And then it validates that services are running healthy, and boom, you're ready to go. So just quickly threw a couple slides in here just to show you that a single configuration runs identical to a 3-node. It's just that you're telling it one node and you're giving it information for only one node. But point I want to make, you still have a virtual IP address. So the model is the same. It's just a 1-node model instead of a 3-node model. It's still running the virtual IP address, and so still using virtual IP address for services. On this one, just some screenshots here. Definition, what I created for a single node install. I ran through a PowerVC install, same commands basically, no difference, just installs on one node instead of three. So when you're all said and done here, we've got the system up and running. This slide just wanted to show how the internal communications are using this virtual IP as well. So if you really look under the covers on how these different components communicate, OpenStack components communicate, Nova in particular, kind of the driver, if you will, of a lot of these services, talks to Cinder, talks to RabbitMQ, all of them do for communications and listening to posting of messages, and needs to set information in the MariaDB or read from MariaDB. So all these internal communications, their configuration files are changed to use this virtual IP address. So the internal services are highly available as well as any of the outside world looking in. Your PowerVC UI, your OpenStack CLI, your OpenStack APIs, all your upward integrators, all use the new virtual IP. If we look at NovaLink a little bit, and this is as deep as I'm going to go into NovaLink here, we can certainly go a lot to NovaLink, but again, allows us to expand and scale to larger numbers because there's a NovaLink LPAR running on each host that is handling all the Nova and Neutron and even some metering components for specifically that host. So rather than your HMC doing it for up to 30 hosts, you have NovaLink doing it for just one host, and they all report back into the control plane for that specific host. So allows you to scale up. Management is kind of compartmentalized a little bit by host. All of NovaLink then, when you install a NovaLink LPAR and control it with PowerVC, it also is configured to use this virtual IP address. So again, all highly available. Let's take a look at day 2 operations. So as I mentioned, we've got a new PowerVC Ops Manager command. You can look at this up in the install in Knowledge Center, or do a help on the command once you get it installed and get some details on the config on the command line. But basically, you saw the inventory, setting up, defining your cluster. You saw the install process for a single node and a multi-node. It also has these other commands. You can apply fixes that'll happen across all of the cluster for PowerVC fixes. There's this idea of a replace node, which is pretty slick. Again, PowerVC is hiding all this from you, which is great. If a node fails on you, you're down to 2 nodes, your services are still up and running. For whatever reason, that node, you can't bring it back up. You don't have it working, the disk failed or whatever the case may be. You can actually create a brand new virtual machine, can even have a different IP address in that same subnet, and you can run this replace node command. It's going to just prompt you, what's your old IP address? What's your new IP address for this node? Boom, Ansible runs, brings in the new node, automatically joins the cluster. Pretty slick. So anyway, that's out there with the same command. Uninstall wipes out everything, obviously, and removes all the software for the cluster, the definitions and so forth. You can add nodes to an existing cluster. So, and we'll go through that in a minute here on how the upgrade works. And then one other thing is the backup and restore for PowerVC are now done through PowerVC Ops Manager command instead of through the PowerVC backup command. So keep that in mind because it's cluster aware. It's going to go out, pull configuration information into your backup file. The backup file is stored on the primary node. So that's the importance of the primary node. It is stored on that node. And then your restore capabilities, obviously, you can go back to a multi-node configuration as well. The original PowerVC types of commands that have been out there for quite a while, all are cluster aware as well. So they do work with a 3-node cluster configuration. Example, your PowerVC services stop and start, right? You can stop and start services. It'll stop and start across all 3 nodes. If you're registering a resource into PowerVC, again, all these things go against all 3 nodes, the virtual IP addresses to register these storage or whatever the case, networks, storage. The configuration of PowerVC. So there's this PowerVC config command that you can use to modify a configuration of a particular service. That again, you can run that command as was. It'll go across and change configuration